So I want to formally welcome you to today's session of the class. We are taking a look at Module 8, which is Address Resolution Protocol. Module 8 is also a very brief chapter, but very, very important. Okay, so we're going to be looking at what Address Resolution Protocol is, and we'll try and also understand how it works and in which environment it is best suited for. Now, MAC and IP. Now, remember in our previous class, we talked about IP as Internet Protocol. And we said that the IP, it's basically a 32-bit binary digit, that is IP version 4, or 128 binary digit, which is IP version 6. But importantly, we said that the IP identifies a device uniquely on a network. That means any device that must belong to any network needs to have an IP address. So it is the IP address that is used to identify the device on the network. We also spoke about the IP as the protocol that runs on the network layer of the OSI model, okay, or the internet layer of the TCP/IP reference model. Now, in the packet header, we understood that the IP is assigned as the source and the destination address to identify how the router routes the traffic. Now, for the MAC, we said the MAC is the media access control, and it is an address that is permanently assigned to the network interface card by the manufacturer, okay, manufacturer of the network interface card. Now, when we talk about address resolution protocol, we are going to be looking at both the MAC and the IP. Now, the MAC address is the address that is used at the data link layer of the OSI model, or the network access layer of the TCP/IP reference model. Now, the two primary addresses assigned to a device on an Ethernet LAN are basically the physical address and or the logical address. Now, the physical address is actually the MAC address, okay? Now, it's actually the MAC address and is used for network interface card to network interface card communications, meaning that I have my system here and I have a router here, a server here. If they are directly connected, we don't need a router. This communication is going to just move between the MAC address, okay? And even if I have a switch located here, what it simply means is that it does not go to a router, okay? It does not go to a router. So the address that is going to require the movement of the frame is the MAC address. So if the destination IP address is on the same network, the destination MAC address will be that the destination device. So since it is, you see, 192.168.1.110 is within the same segment or network as 1.50. They are both /24. All right. You don't need, the traffic does not need to come to the router to get here. So it means that there is no need for routing. Okay, it's just going to come directly from here to here. Now, the guy that is going to help him know how to get to this destination is the MAC address table that is on the switch. Okay, now that's where it becomes interesting. We're going to look at that. Now, the logical address is used to send packets from the original source to the final destination. Now, the logical address is the IP address now in this case, the IP address, okay? The destination IP address may be on the same IP network as the source or may be on a remote network. So if you are using IP address, basically like we have here, it's actually used to identify the source and the destination device. So the IP address is like layer 3. Look at it here, the layer 3, which is the network layer. Okay, so we have the source and the destination. The source address is the address of PCA. The destination address is the address of the server. But look at the MAC addresses. That's the layer 2, which is layer 2 information. The source MAC address is, look at it here, 0000-0B. Then the destination MAC address, destination MAC address 000B, which is this guy here, 000B. The source MAC address is 000A, which is this guy here. Okay, so on a simple network, you have your PC here, you have another PC here, and you have a switch that comes here. So this PC connects here on, let's say, port 1, and this PC connects here on maybe port 2. Now, inside this particular switch, there's what they call the MAC address table or the CAM table, where it's going to pick this port 1 has the MAC address. Maybe the MAC address here is 0008. Let's just say 0A, for instance, 0A. Okay, and then for port 2, it will have the MAC address, let's say 0B. Okay, so this PC1, this PC2. PC1 is on port 1, PC2 is on port 2. Now, even if you have an IP address 192.168.1.110 as we have here, what it means is that if your packet comes to this particular switch, it will have the destination address of 1.50, 1.50. That is this IP address here. Okay, now this is the destination address. So once it gets to this switch, it is looking for 1.50, but it does not know how to get to 1.50. Remember, 1.50 is on port 2, which is 0.2. Okay, but it doesn't know how to get to this 1.50. So we're going to find out. That is where address resolution protocol comes into play. So when the destination IP address is on a remote network, the destination MAC address will be the address of the host default gateway. The process in this image explains it. Okay. Now, in the previous slide, you have seen the scenario where they are on the same network, where you don't need a router. But in this case, look at it. This particular PCA is trying to get to this destination. You see, they're definitely on a different network, 192.168.1.110, and this guy is 172.161.99. There are two different networks, okay? And so this particular PC will have to be routed. This is the router, will have to be routed to this router, and then before it gets here. So how is the communication going to take place? What will happen is, you see, there's a switch here. Okay, so 000A is the MAC address here of this PC. All right, and 000C is the MAC address of the interface of this router, the MAC address of the interface. So when this 000, this PCA is sending, he's going to forward the frame directly to this MAC address here. He does not need to forward it to the MAC address of this particular device. No, it's going to forward it to the MAC address of this interface. All right. And so this is going to be its destination MAC address. So when the router receives the frame, it's going to decapsulate it and then remove this MAC address as the destination and remove this as the source, then re-encapsulate it. Then the new source is going to be the MAC address of this interface here, the new source MAC address, and the destination MAC address will be the MAC address of this interface here. Okay, so once it gets, the frame is forwarded here, there will be decapsulation, then there will be re-encapsulation again, then the new MAC address will be this guy here and this guy here. Now that is how it's going to be moving. So routers examine the destination IP version 4 address. When the router receives the Ethernet frame, it decapsulates the layer 2 information. The layer 2 information is the MAC address that we're talking about. That's the frame. Now, using the destination IP address, the router determines the next hop device and then encapsulates the IP packet in a new data link for outgoing interface. If the next hop device is the final destination, the destination MAC address will be that of the device's network interface card. So you see, this is the layer 2 communication in the header. Is going to be dealing with destination MAC address is what? 0C, which is this guy. The source MAC address is what? 0A, which is 0A, which is this guy. So this is going to be the source, this will be the destination. Okay. Now, once this router examines the layer 3 information, which is this guy, then there's going to be, it's going to forward a re-encapsulation, and then the MAC address of here and here will be initiated. And that is how it's going to be moving. Now, how does ARP comes into play? The figure illustrates a problem while sending a packet to another host on the same local network, IP version 4 network. Because the IP address is known, but the MAC address of the device is not known. Okay, this is this guy, H1, and he says, I need to send information to 192.168.1.7, which is H4. Okay, this H1 wants to send information to H4, but I only have the IP address. I don't know the MAC address of that device. So it, once it's encapsulating, it knows that the destination IP address is this guy. Okay, now remember that this switch here has a table. Okay, it has a table. So maybe this guy is on port 1, this is on port 2, this is on port 3, maybe this is on port 4. Okay, so they are all connected to this switch. Now this table, on each of these ports, it has the, maybe it needs to have a MAC address. Port 2 need to have a MAC address, port 3 have a MAC address, port 4 need to have a MAC address. Okay, so we need to have the MAC addresses in here like this. For port 1, we know the MAC and the same. So it says a device uses address resolution protocol, ARP, to determine the destination MAC address of the local device when it knows the IP version 4. So how does it do that? It does two things. One, it resolves IP version 4 addresses to MAC addresses. And then two, maintaining the table of IP version 4 to MAC address mappings. So remember, we have this MAC address table, then it has the table that maps the IP address to the MAC address. Okay, it maps the IP address to the MAC address, meaning that apart from this table, there is an ARP table where it's going to say, okay, for this MAC address 0001, it has this IP address. Okay, so it's going to map it. Right now, let's see how it's done. It says when a packet is sent to the data link layer to be encapsulated into an Ethernet frame, the device refers to a table called the ARP table, okay, or the ARP cache in the memory to find the MAC address that is mapped to IP version 4 address. Okay, the sending device will search the ARP table for destination IP version 4 addresses and a corresponding MAC address. If the packet's destination IP version 4 address is on the same network as the source address. If the device locates the IP version 4 address, its corresponding MAC address is used as a destination MAC address in the frame. Now, this is what we are saying here. This guy says, I must send out an ARP request to learn the MAC address of the host. But before I use this example, let me explain the two tables, the MAC address table and the address resolution protocol table. They are all for the switch, right? So the switch has, let's see the MAC address table. Now, like I said in the previous slide here, where every system is connected to a port. You see, these ports that are here, they might be empty. All right, this is port 1. There's no MAC address there. Port 2, there's no MAC address. Port 3, no MAC address. Port 4. So if port this particular H1 wants to send information to H4 or maybe H3, the frame comes to this particular table. But since it does not know which port, it knows the destination MAC address, but it doesn't know which port. Because in the frame header, remember in the frame header, there is the source MAC address, and then there is the destination MAC address in the header. Now, once it comes here, there will be a decapsulation. And in the decapsulation, the source MAC address says, okay, this information is coming from this, so is a source. I will get that. So since it's coming from a source, then it's going to now check, okay, this is port 1. So port 1 has a MAC address. So the MAC address here that is in this source will be populated in this port number. Now, but it doesn't know the port that the destination is located. So since a switch is a broadcast address, it's going to send the information through all the three ports, except the source. So if the message is for H4, H4 will now respond. Okay, once H4 is responding, you see this is port 4. It's going to respond with its own MAC address. So the MAC address of this guy will be populated. Now this will go on. Anytime this H1 wants to communicate with H4 again, it does not need to go through a broadcast. All right, this broadcast is called a broadcaster. So there's no need for this broadcast. So the message will be sent directly to H4. Okay, so but now if there's going to be a message to H2, so the message will now be broadcasted again, and when H2 responds, then the MAC address will be populated here. The same thing when it goes for H3, the MAC address. So if the CAM table is fully populated, then anytime anybody is sending any message, any system is sending a frame, the destination, you don't need a broadcast, it just goes direct to the table and sends this information. But the problem that we're trying to address here is that if this particular system is sending a message, remember it is going to encapsulate the message with the destination MAC address. but he does not know the MAC address. He does not know the destination MAC address. So the only way to find the destination MAC address is to come to another table, the ARP table. Okay, the address resolution protocol table. Now, this table keeps information. You see, the previous table keeps information of port number and MAC address, but the ARP keeps information of MAC and IP. Yeah? It has MAC address and then the IP address. MAC address and then the IP address. MAC address and the IP. So if you can get the IP, then it is easy to get the MAC address. All right. So I must send out an ARP request to learn the MAC address of the host with the IP address 192.168.1.7. Remember, this is the 192.168.1.7. Okay. So what will happen? This guy will now send the message to the switch, the frame, and this frame will now send a broadcast. Remember, we said a switch is a broadcast device. It's now going to send a broadcast. Now, in the broadcast, what is he going to send? He will say, who has this IP address? Who is the owner of this IP address? I need your MAC address. Send me your MAC address. So once he sends this broadcast, you see, this guy will respond and say, it isn't me. This guy will say, this isn't me. How did they know they are not the ones? Because their IP address does not match the query that was sent by H1. And then if this guy says, yes, this is me, I will send back my MAC address. So when this guy is sending the MAC address, it's going to be populated based on the address resolution protocol. So it says that the sending device will search its ARP table for destination MAC address and a corresponding MAC address. If the packet's destination IP version 4 address is on the same network as the source IP address. If the device locates the IP address, its corresponding MAC address will be used as the destination MAC address in the frame. Okay, so that is mostly when you are within the same network. Now, for each device, an address resolution protocol cache timer removes the ARP entries that have not been used. So every PC, my PC, your PC, keeps the address resolution table. The timer clears it once it counts down to 0. Okay, so commands may also be used to manually remove some or all of the entries in the ARP table. So after an entry has been removed, the process of sending the ARP request and receiving an ARP reply must occur again to enter the map in the table. All right. Now, how do you do that? All right. On a Cisco router, all you just need to do is type the command show IP ARP. Show IP ARP. Once you use the command show IP ARP, it's going to bring out for you the details. For instance, the IP address and the corresponding MAC address and possibly the interface. Okay, show you the IP address, the MAC address, and possibly interface. IP address, MAC address, and possibly interface. But if you are using it on your own PC, all right, maybe on your computer, Windows PC, if you just do ARP space -A, it's going to give you the IP address and the MAC address. The IP address and the MAC address. The IP address and the MAC address. For instance, let me even do it on my system. Let me share my, okay, let me see, where's my command prompt? Okay. So now this is my command prompt here. I believe you can see it. Okay, so okay, ARP minus A. Okay, so if I do that, now look at, this is the details that I get. I'll get the IP address and the MAC address. The IP addresses and the MAC address. The IP address and the MAC address. Okay, IP address, MAC address, IP address, MAC address, IP address, MAC address. That is the address resolution protocol. So if there is a query, they have an IP address but they don't have a MAC address, you just check this table and then forward the corresponding MAC address. Once that is done, everything just goes fine. Okay, so what are some of the issues that are bound to happen? First of all is broadcast. As a broadcast frame, an ARP request is received and processed by every device on the local network. So it sometimes overwhelms the network. Remember that this is a switch, and the switch has all these ports. So once an ARP request is sent by one device, it goes through all of them and all of them have to process it. So you can imagine when this is being sent multiple times. That's why if you're running a managed switch, it's always good to allow this. Don't be rebooting it all the time, because each time you reboot it, it's going to now send a broadcast stump. So on a typical business network, this broadcast would have a minimal impact on network performance. If many devices start accessing the network service at the same time, there can be reduction in performance for a short time. Okay. After the device sends out their initial ARP broadcast and have learned the necessary MAC addresses, any impact on the network will fail. All right, will be minimized. Okay, so it is important that that we understand the impact. Now, another issue that is bound to happen, apart from broadcast storm, is ARP spoofing. Now, when we say spoofing, spoofing is like uh, trying to be someone that you are not, okay? Picking somebody's name or MAC address and claiming to be you, all right? Now, spoofing is a security breach, it's an issue in security. So the use of ARP can lead to a potential security risk in some cases, because somebody might hack into your switch and then try to generate an ARP. It says, I will send an ARP reply and pretend to be the default gateway, right? So if it pretends to be the default gateway, then every device that wants to go out to the internet, this is where, instead of them to come like this to the internet, they will just go straight this way. Instead of them coming down, they will just go straight this way. And so this device, the hacker will now be manipulating the traffic, okay, manipulating the packets. All right. So it is a technique used by a threat actor to reply to an ARP request for IP version 4 addresses belonging to other devices, such as default gateway. The threat actor sends an ARP reply with its own MAC address. The receiver of the ARP will add the wrong MAC address to the ARP table and send the packet back to the threat actor. So ARP spoofing is bound to happen anytime there is this broadcasts that are being sent. Okay, so I think that is that about that. That is the end of, like I said, it's a very short topic, but a very interesting one. So, any questions?